In this video, we are going to look at some problems on photoelectric effect. In a photoelectric experiment, light of wavelength 3.5 times 10 to the negative 7 meter is incident on a metal plate. Electrons, so that's our lambda. Electrons with a maximum kinetic energy 5.2 times 10 to the negative 19 joules are emitted. That's Ke max. Find the energy of each incident photons in joule. So the formula for energy is hc over lambda. We have got h and c, which are constants, and lambda is given in the problem itself. We got the answer and put the unit as joules. Find the work function of the metal. Now, because they have not given us the threshold wavelength, so we will use the formula E photon is equal to phi plus Ke max. Substitute the numbers for E photon and Ke max, and then we can get the answer for phi, which is 5 times 10 to the negative 20, and don't forget the unit, joules. Work function is also energy, and that's why the unit will be joules. Find the threshold wavelength. So we can use the formula for work function, that is hc over lambda O or lambda 0, which is the threshold wavelength. Substitute the numbers and we get the answer as 3.96 times 10 to the negative 6, and the unit is meter. Next, we have got a multiple choice here. Light of wavelength 600 nanometer is incident, and we want to find what's the energy of the incident photon. We can also see that all the answers are given in electron volt. So we'll use the formula E equal 1240 over lambda, where lambda should be in nanometer, to get the energy in electron volt. So we already have the wavelength in nanometer. We can just substitute that. We get the answer as 2.1 electron volt. So that's what we want to remember when we use the formula E equal 1240 over lambda. If lambda is in nanometer, we get the energy in electron volt. Next, electromagnetic radiation is incident on a metallic surface. Electrons are emitted from the surface when the wavelength is 450 nanometer or less. What is the work function of the metal? So the formula for work function is hc over lambda O or lambda 0. So lambda 0 is given to us 450 times 10 to the negative 9, because it's given in nanometer. So we'll multiply by 10 to the negative 9. We can substitute it into the equation. We get the answer as 4.4 times 10 to the negative 19, and the unit is joules. What is the stopping potential required to stop photoelectrons ejected by the plate when the incident light has a wavelength of 300 nanometer? So now, stopping potential and kinetic energy max are related by this formula. So we want to find what's the kinetic energy. So we'll use the formula E photon equal phi plus Ke max. But we can see that the wavelength, the incident wavelength is 300 nanometer. So we'll use that to find E photon. That's our first step, which will be 6.6 times 10 to the negative 19 joules, which we put in place of E photon. Phi we calculated in the first part, so we can use the same number, plus Ke max. Rearrange the formula to get Ke max. Now we can find what is stopping potential. So we'll use the formula for Ke max equal negative E delta Vs, where delta Vs is the stopping potential. And then we can substitute E as 1.6 times 10 to the negative 19. That's the charge on the electron. And we get the answer as negative 1.375 volt. So E, which is the magnitude of the charge on the electron, that's why we are putting it as 1.6 times 10 to the negative 19. So our answer is coming as negative 1.375 volt. Negative is telling us that the stopping potential is applied in such a way that the electrons stop, or the photoelectrons ejected by the plate are stopped. So that's why it is negative. So it is in the opposite direction, because you have to stop the electrons from moving. Next, we have a problem on Compton effect. What is the greatest change? So the question is asking for greatest change. So we can see that Compton effect is when the photon collides with the electron. If you want greatest change, the photon should have bounced back. That means it should reflect back. So the angle will be 180 degrees. Angle by which the photon gets deflected from its original path is 180 degrees. We have got the formula for Compton effect. We can find the change in wavelength by substituting the numbers, and in place of theta we are going to put 180. H is Planck's constant, me is mass of electron, c is the speed of light. These are all constants. We can substitute and get the answer for the greatest change in wavelength as 4.84 times 10⁻12 meter.